Good morning students, this is SHAFI from Don Bosco PU College, Chitradurga. In our previous class, we learned the important derivation that the equation of a plane in normal form both in vector and Cartesian form. I hope you understood the concept of deriving the equation of a plane. In this class, we are going to learn the problems that based on the previous derivation. What is the vector form of the equation of a plane in normal form? The vector form of a equation of a plane in normal form is what? R dot n cap equals to d. R dot n cap equals to d, isn't it? Now n cap is nothing but what? N cap is nothing but what? Unit normal vector, where n cap is nothing but a unit normal vector. N cap equals to now in our vector algebra we have one important note point that a unit vector along the vector A is what? A unit vector along the vector A is what? A unit vector along the vector A is what? A cap equals to A vector divided by magnitude of A vector. This thing already we have learned in our vector algebra. Now here we have n cap. How you are going to define this unit normal vector n cap? A cap is A vector by magnitude of A vector. N cap is what? N vector divided by magnitude of n vector. Right? The equation of a plane in normal form is R dot n cap equals to d, where n cap equals to n vector divided by magnitude of n vector. So it is the vector form. Now Cartesian form. What about the Cartesian form? In our derivation we derived that Lx plus My plus Nz equals to d, isn't it? Lx plus My plus Nz equals to d. But in the problems we will consider, or we will take it as Ax plus By plus Cz equals to d. If you want to take, you can take Lx plus My plus Nz equals to d. Then what is the difference of it? Here A, B, C are the direction ratios of the normal. Here A, B, C are the direction ratios of the normal. If the equation of plane will be like this, Lx plus My plus Nz equals to d. Then here L, M, N are the direction cosines of the normal. If the equation of a plane will be given like this, Ax plus By plus Cz equals to d, then here A, B, C are the direction ratios of the normal. Here L, M, N are the direction cosine of the normal. You just write down that points. Here direction ratios. This dr represents direction ratios of the normal. Direction ratios of the normal are A, B, C. What about the direction cosines? L, M, N. Direction cosines of the normal. Direction cosines of the normal are, in the starting of this chapter I already told you, and also we have solved so many questions for finding the direction cosines. What is the formula to find the direction cosines? Direction cosines are denoted by L, M, N, isn't it? Direction cosines are denoted by L, M, N. How to find? L equals to A by square root of A square plus B square plus C square. You just write down that L equals to A divided by square root of a square plus b square plus c square. Next, m equals to b divided by square root of a square plus b square plus c square. N equals to c divided by square root of a square plus b square plus c square. Direction cosines are denoted by L, M, N. How to find the direction cosines of the normal? A by square root of a square plus b square plus c square, b by square root of a square plus b square plus c square, c by square root of a square plus b square plus c square. It is the direction ratios and it is the direction cosines. Once again, if the equation of a plane is given in vector form, if the equation of a plane is given in vector form, then it is the formula to find the equation of a plane. Suppose if the equation of a plane is given in Cartesian form, suppose the equation of a plane or anything related to the Cartesian form, it is the formula and it is the concept to find the equation of a plane in Cartesian form. Understood? Now, in this we have some other points. Kindly note down. First, perpendicular distance. I already told you that this symbol represents perpendicular. Perpendicular distance. How to find the perpendicular distance in the equation of a plane? Perpendicular distance equals to d divided by square root of a square plus b square plus c square. Perpendicular distance is d divided by square root of a square plus b square plus c square. Okay. Now, if the equation of a plane is given like this: Lx plus my plus nz equals to d. Lx plus my plus nz equals to d. Here also L, M and N are the direction ratios we will take. Here also L, M and N also will take it as a direction ratios. Direction cosines, then direction cosines of the normal are a by square root of a square plus b square plus c square, b by square root of a square plus b square plus c square, c by square root of a square plus b square plus c square. If you are getting confused to relate it to this point, you can ignore it. Kindly do not confuse. If you are going to confuse this point, you can ignore it. The next point, the foot of the perpendicular. Foot of the perpendicular is. How to find the foot of the perpendicular? Related to this one, I mean the foot of the perpendicular, you already learn about this word in your first year PUC. No need, I think you no need of so much explanation related to this one. Foot of the perpendicular is LD, MD, ND. Foot of the perpendicular, it is the formula to find the foot of the perpendicular. Foot of the perpendicular is LD, MD, ND. So these are the note points which we are going to use for problems. You kindly note down these note points in your notebook. So it is the vector form. You just take a screenshot or you just pause the video and note down in your notebook. It is a vector form and it is a Cartesian form, and here we have the perpendicular distance, and here we have the foot of the perpendicular. So it is the concept of the equation of a plane. Now let us going to solve the problems related to these note points. So it is the first question, that find the vector equation of the plane which is at a distance of 6 by square root of 29 from the origin, and its normal vector from the origin 2i cap minus 3j cap plus 4k cap. Here we have to find the vector equation of the plane. We have to find the vector equation of the plane, right? Now vector equation of the plane is what? You just remember the points what we have discussed in our note points. Vector equation of a plane is what? Vector equation of a plane is what? R dot n cap equals to, it is the vector equation of a plane. R dot n cap equals to d. What about a unit normal vector n cap? N cap is what? N vector divided by magnitude of n vector. N vector divided by magnitude of n vector. Now, for to find the vector equation, what he is given in the problem? For to find the vector equation, what he is given in the problem? Find the vector equation of the plane which is at a distance of, distance is given 6 by square root of 29 and normal vector is given. Two things are given. By using these two things we have to find the vector equation. It is the vector equation. We have to find the vector equation. You just write down the given things. Given that the distance d is given, d equals to 6 divided by square root of 29. 6 divided by square root of 29. Distance is given. Next, unit normal vector is given. Normal vector is given, sorry, it is a normal vector. Normal vector is given. That normal vector is what? N vector. N vector equals to 2i cap minus 3j cap plus 4k cap. 2i cap minus 3j cap plus 4k cap. Now we have to find a unit normal vector. R dot n cap equals to d. D we have, right? D we have. N cap we have to find. N cap we have to find. How to find n cap? N cap equals to n vector divided by magnitude of n cap. N vector already we have. N vector is already we have. We need to find magnitude of n cap only. We need to find magnitude of n cap. Sorry, magnitude of n vector. Here itself you just find out the magnitude of n vector equals to square root of, how to find its magnitude? I component square 2 square plus j component square, that is minus 3 whole square, plus k component square, that is 4 square. That is equals to how much? How much the value of it? 4 square is 16. 16 plus 9 is 25. 25 plus 4 is 29. Square root of 29, right? Now we just write down the equation of a plane, or we just write down a unit normal vector. That is, therefore n cap equals to n vector divided by magnitude of n vector. N vector divided by magnitude of n vector. You just substitute the vectors in this. N cap equals to n vector. N vector what we have? 2i minus 3j plus 4k. 2i minus 3j plus 4k. Magnitude of n vector, square root of 29. Square root of 29. Okay. Square root of 29. Now write down the equation of a plane in vector form. Equation of a plane in vector form. Therefore the equation of a plane in normal in vector form is, therefore the equation of a plane in normal in vector form is r dot n cap equals to d. R dot n cap equals to d. Now you just substitute the values of n cap and d in this equation. That is, the required equation of a plane. R dot n cap what we have, 2i minus 3j, 2i minus 3j plus 4k divided by square root of 29, 2i cap minus 2i cap minus 3j cap plus 4k cap divided by square root of 29 equals to d. D is given d by 6 by square root of 29, 6 divided by square root of 29. Hence it is the equation of a plane in vector form. If you want to simplify further, you can simplify by cancelling square root of 29. Square root of 29 will get cancelled. Okay, that if you want to simplify, you can simplify, or else you can stop here itself. It is the first problem. Kindly note down in your notebook. Given things are d is given, n vector is given. By using this, I just find it out magnitude of n vector. After that, n cap I find it out. After that, I just taken the equation of a plane in normal in vector form. I just substituted the values of n cap and d in this equation. Finally, we get the equation of a plane in normal form. Now, note down the one more question. That question will be homework for you. Write down the question. That question will be homework for you. Find the vector equation of the plane. Find the vector equation of the plane which is at a distance of 7 from the origin, and its normal vector from the origin is 3i cap plus 5j cap minus 6k cap. It is also very similar to the previous one, just values are changed, that's it. It is the question homework for you. D is given, n vector is given. You just find out the equation of a plane in vector form. Okay. Now let us move to the third question. Find the direction cosines of the unit vector. It is a third question. Find the direction cosines of the unit vector perpendicular to the plane r dot 6i minus 3j plus 2k plus 1 equals to 0. Here we have to find the direction cosines, not the equation of a plane. We have to find the direction cosines. Equation of a plane is given. By using this equation of a plane, we have to find the direction cosines. How to find the direction cosines? Let us find out the direction cosines. You just write down the given plane. Let r dot 6i cap minus 3j cap plus 2k cap plus 1 equals to 0. First of all, we have to represent this plane in the form of r dot n cap equals to d. We have to represent this plane in the form of r dot n cap equals to d. So that we have to shift this plus 1 to the right, that will be negative, that is minus. r dot 6i cap minus 3j cap plus 2k cap equals to, shift this plus 1 to the right, that will be minus 1. That will be the minus 1. Next, and also this d always should be measured as a positive one, so that we have to make it as a plus 1. How to make it as a plus 1? Here we have the minus 1. It is a d. The right hand side what we have, that's a d. D is nothing but a distance. Distance we measured always in a positive quantity, so that this minus 1 we have to make it as a plus 1. How to make it as a plus 1? By multiplying minus on both sides, or by applying minus on both sides. You just make it as minus 1 to plus 1, so that I am applying minus on both sides or multiplying minus on both sides. Or dot, I am applying minus, plus 6 will become minus 6 I cap, minus 3j will become plus 3j cap, plus 2 will become minus 2k cap, equals to minus 1 will become plus 1. Since we have done that multiplying minus on both sides, multiplying minus on both sides. Now it is a n vector. It is a n vector. Now n vector equals to minus 6 I cap plus 3 j cap minus 2 k cap. We have to represent this plane in the form of r dot n cap equals to d. R dot n cap equals to d. We have to represent this plane in the form of r dot n cap equals to d. I am just representing this plane in the form of r dot n cap equals to d. It is not a n cap. It is not a n cap. It is a unit vector. It is a normal vector. That is a n vector equals to minus 6i plus 3j minus 2k. Now we have to find n cap. N cap is nothing but n cap equals to n vector divided by magnitude of n vector. We have to find n cap, unit normal vector we have to find. After that we have to substitute this value in this equation. Then we will get the direction ratios, so that you just find out magnitude of n vector. Magnitude of n vector equals to square root of minus 6 whole square plus 3 square plus k component minus 2 whole square equals to square root of how much? The value it will be minus 6 whole square is 36 plus 9 plus 4. How much? The value of this 49, square root of 49, that is 7. Magnitude of n vector is 7. Magnitude of n vector is 7. The next thing, you just find out n cap. You just find out n cap. N cap equals to n vector divided by magnitude of n vector. N vector is nothing but minus 6i plus 3j minus 2k divided by magnitude of n vector is 7. Magnitude of n vector is 7. You just substitute n vector and magnitude of n vector in this. We will get a unit normal vector, that is n cap. N cap equals to n vector is minus 6i plus 3j minus 2k divided by magnitude of n vector is 7. Magnitude of n vector is 7. Now magnitude of n vector is 7. Now we just here we have in the denominator 7 for I component, j component and k component. You just separate it. Then we will get minus 6 by 7 I cap plus 3 by 7 j cap minus 2 by 7 k cap. Minus 2 by 7 k cap. Now in this unit normal vector we have the direction cosines. The direction cosines are minus 6 by 7, 3 by 7 and minus 2 by 7. Therefore the direction cosines are minus 6 by 7, 3 by 7 and minus 2 by 7. Right? Minus 6 by 7, 3 by 7 and minus 2 by 7. Hence it is the procedure to find the direction cosines of the plane. You just write down in your notebook. You just write down this question in your notebook. Here one plane is given I just modified this plane. It has r dot minus 6 I cap plus 3j cap minus 2k cap equals to 1. After that, here we found the vector n vector. N vector equals to minus 6i plus 3j minus 2k cap. After that, we have to find its magnitude. Magnitude will be 7. After that, we have to find its unit normal vector, or n cap equals to n vector divided by magnitude of n vector. Finally, we will get a unit normal vector. Finally, we will get a unit normal vector. In this unit normal vector, we will have the direction cosines. These are the direction cosines. Hence, it is the problem. One more question we have. That question will be homework for you. You just do that question at your home. It is the question 4th one, homework for you. Find the direction cosines. Find the direction cosines of the unit vector perpendicular to the plane r dot 3i cap minus j cap plus 6k cap minus 2 equals to 0. Find out the direction cosines of the unit vector perpendicular to the plane. It is the one homework for you. Okay, dear students, it is the class for today. In the next class, we will continue the problems. Still, we will have some other problems based on this equation of a plane. In the next class, we will continue. Thank you.